Welcome to my channel. In this video, we are going to learn combination of resistances, series and parallel. Apart from potential difference, current in a circuit depends on the resistance of the circuit. In the electrical circuits, usually it is necessary to combine two or more resistances to get the required current in the circuit. We use various electrical gadgets where we need these system of resistors, or I call this as combination of resistors. Now, what are those different combinations that we have in which we can combine resistances to get the required current in the circuit? Number one, series resistance. So, you can add resistances in series. For example, let us look at, I have taken two resistances R1 and R2, and these two are connected in series. In series means they are connected end to end. A, B is the end, and this is the end or beginning of R2. So, end to end. So, these two are connected like this. See. AB is one resistance, BC is one resistance. So, B is the common point connected end to end. Then the second one is parallel. Now, parallel is, again I have taken two resistances R1 and R2, and these two resistances are connected between the same points A and B. So, R1 and R2 are connected, and the end points for these two resistances are the same, and that is A and B. Now, if I calculate the total resistance, that I call it as equivalent resistance or combined resistance or resultant resistance, whatever it is. We will discuss that. It increases in the series combination, and it decreases in the parallel combination. How? We will see. So, we will begin with resistances in series. The combination of the equivalent resistance when we have taken resistances in series like this. So, I am considering, let us say I have three resistances in series. For example, I have R1, R2, R3. So, if I have taken R1, R2, R3 in series like this, then the combined equivalent resistance, or I can call this as resultant resistance, or the total resistance, is equal to R1 plus R2 plus R3. That is, the combined resistance of any number of resistances connected in series is equal to sum of the individual resistances. Sum of the individual means R1 is the individual, R2 is individual, R3 is individual for the resistances 1, 2 and 3. So, this is resistance 1, 2 and 3. These are the resistances of these three resistors. Now, there are two important points which we need to understand, for which let us look at this circuit. If V is the voltage of the battery connected to the series combination of resistances. Now, here in this example, I have taken only two resistances. So, I have resistance R1, resistance R2. They are in series, points A, B and C. So, B is the point where they are connected end to end. And then it is connected to a voltage V of the battery. So, this is V, this is the battery, and this is the switch, and to measure the current in the circuit, I have an ammeter. Now, as we know, current flows from positive to negative. So, the direction represents like this. So, it is the direction of the current. So, positive to negative. Now, I will explain these parameters through these points. Now, point number one is each resistance has a different potential difference. I have shown you V1, V2. So, each resistance has a different potential difference. So, this is important, different potential difference, but the total potential difference is equal to voltage of the battery applied. What does that mean? That is sum of potential difference across all resistances is equal to the total voltage of the battery applied. So, V, which means I can write this as V1. V1 is the voltage which is I have shown you, and we know that a voltmeter is connected in parallel. So, I have shown you this V1 and V2. V1 and V2 are the voltages across R1 and R2. So, V1 plus V2 is equal to V. V1 plus V2 is equal to V. Next point, same current I flows through the each resistance, which is equal to the current flowing through the whole circuit. Same current flows. So, what is the current flowing? I. So, you can see that I have represented I here, I here. So, the same current flows. So, this is the direction of the current. So, this is the direction of the current, this is the direction of the current. So, I flows through the circuit. So, say which is the total current. So, total current through the circuit and the same current will flow through the circuit. V1 by R1 is same as V2 by R2 is same as I, which is equal to V by R, the total voltage by total resistance R. So, same current I flows through the each resistance. So, if I consider I through R1, so that is V1 by R1. The current I, same current through R2, V2 by R2, and that is equal to the total current, equal to current flowing through the whole circuit, current flowing through the whole circuit. So, same current flows. So, this is the equation. Now, let us derive the resultant resistance. So, we will consider the equation V1 plus V2 is equal to V from the first point. This is the point. V1 plus V2 is equal to V, and I is equal to V1 by R1 is equal to V2 by R2. So, V1 is equal to IR1, V2 is equal to IR2. Therefore, now let us put this as equation 1. So, I will substitute. So, IR1 plus IR2 is equal to V. Now, what is V? V is, so I can write this as IR1 plus IR2 is equal to IR, since according to Ohm's law V is equal to IR. So, here V is the total voltage, total current and total resistance. From this we can write R1 plus R2 into I is equal to IR. So, R1 plus R2 is equal to R. So, this is the important equation. From this we can understand that the resultant is always greater than the individual resistances, either R1 or R2, because it is a sum of these two. So, this is the point that we have seen. So, it increases, the resultant resistance or the total resistance increases in series combination. Then we will see resistances in parallel. The combined equal resistance is given by this expression. The reciprocal of the combined resistance, reciprocal means 1 by R. The reciprocal of the combined resistance of a number of resistances connected in parallel is equal to the sum of the reciprocals of the individual resistances. So, sum of the reciprocals of individual means 1 by R1 plus 1 by R2 plus 1 by R3, etc. So, if V is the voltage of the battery connected to the combination of resistances, then let us see this equation, circuit. So, between the same points A and B, I have R1 and R2 and voltage, battery, switch and current measured through ammeter, and the direction of the current will be plus to minus. So, it will be the total current I which will be flowing through, and that is the direction. Now, the important points here is, number 1, the potential difference across each resistance is the same, unlike in series resistance where we had different. So, V1, V2, but here it is the same. So, I have this connected here. So, potential difference will be the same across any resistance that you measure, which is equal to the voltage of the battery applied, and this actually depends on the individual resistances. So, I can write this as potential difference across each resistance. So, V1 is equal to V2 is equal to, each resistance is the same. So, is the same, and which is equal to voltage of the battery. So, let us write this equation as V1 is equal to V2 is equal to I. Now, I will write that equation I1 R1 based on this second point. Let us see. Different currents flow through each resistance. So, because this is a common point and here the current is getting divided. So, here the current is I1 through R1 and here the current is I2 through R2. So, I1 is through R1 and I2 is through R2. So, if I measure that, the voltage values I1 R1 is equal to I2 R2. So, that is equal to V is equal to IR. So, that is what it is. Now, different currents flow through each resistance, as I have shown I1 and I2. They get divided, but the currents flowing through all resistances taken together is equal to the total current. That means I1 plus I2 plus I3, if I consider all the different currents flowing through each resistance. So, I1 plus I2 plus I3, since I am not considering the third resistance, okay, let us put it as I1 plus I2, which is equal to the total current I. Now, what is I1 in terms of the voltage and resistance? Here I1 will be equal to V by R1 because voltage by resistance. Similarly, I2 is equal to V because the potential difference is the same. So, V by R2. So, V by, okay, time being we will put it as V1, V2, later on we can equate. So, V1 by R1 is equal to plus V2 by R2 is equal to V by R. But we know from the resultant resistance, we will consider the resultant resistance. How do we calculate resultant resistance? I is equal to I1 plus I2 and we have written this as V1 by R1 plus V2 by, let us put this as equation 1, V2 by R2. Now, I can write it as V by R, but we know that V1 is equal to V2 is equal to V. Therefore, I can write this as V by R. So, this equation 2 I can write it as V by R is equal to V1 by R1. So, V1 is equal to V2 is equal to V. Therefore, I can replace this V1 with V. So, V by R1 plus I can replace this V2 also with V by R2. So, V by R is equal to V times 1 by R1 plus 1 by R2. So, I can take this V cancelled. So, 1 by R is equal to 1 by R1 plus 1 by R2. So, obviously, this is the expression for the equivalent resistance in case of parallel combination. As we can see that it decreases the resultant, it decreases the resultant resistance. In my next video, we will discuss the heating effects of current. Until then, keep watching, keep learning. Thank you.